On Delete Cascade is what this video is about. I've used it actually. I was the only one who knew about it at my old job, and we needed it, and I introduced it. It's dangerous though, and here's why. It's because it kind of violates one of the basic principles about creating a relational database, these constraints that ensure integrity, referential integrity specifically. So let me just tell you the scenario first, so it might make a little bit more sense. So where I worked, there were projects that were created, but spanning a bunch of different tables. So there were all kinds of different primary key, foreign key relationships. But they were about projects as a portal to projects. So there would be like, tables for the client, tables for the different parts that are part of the display that goes together. Because it was principal group's the name of the place. It's branding organization. So they did like signage and stuff. They did Cricket. They did Canova. So like what would happen sometimes, the scenario would be like the project managers would maybe create a project in the portal, but it was kind of half done, or it was like a duplicate of another one, or they kind of just wanted to start over, whatever the deal was. They would want to get rid of the old project, and then when they tried, they couldn't because the database wouldn't let them. They'd be like, delete all this. And if you want to delete tables that have referential integrity, there's a certain order. You have to delete from child tables back to the parents. So let me just show you the example here. We have this product vendor table we've been working with. It has just that kind of relationship. It's a one-to-many. So the primary key of the vendor is going to appear as a foreign key in the product table. So let's just show that. So you see how you got V code. That's the primary key of the vendor table. And if you look at the product table, you want to know which vendor each product comes from. You look at the foreign key. That tells you who the vendor is, right? And you have to do a join to get the name or whatever. Because of referential integrity, you cannot delete. Let's go back and look at the vendors. And this was the scenario we were running into. You can't delete any of these projects, right? Because the ID for these projects appear as foreign keys in like subparts of the project. So that's in my terms. But in this case, you can't delete any of these vendors if any of these products have this vendor as a foreign key. So for instance, I know Bryson's in some of them. So if you try, like say, we're going to fire Bryson, we're not going to get stuff from them anymore. So let's get rid of them in the database. So you delete from vendor where V code, the primary key, is equal to what? Bryson, I said, right, the first one. It's pretty straightforward. So where it's equal to 21225. So let's run that query. Uh-oh, can't do it. Violates the referential integrity. Why? Because if you look at the product table, you'll see that Bryson is in here several times. What was it again? 21225. So 21225. So the way you're supposed to properly do this, and this is in this scenario, this is how you would do it. You would update the product table so that 21225 never appears here. So effectively what you would probably be doing, you would be like ordering your product. Well, you'd either delete the product entirely from, you can't get it anymore because you fired Bryson, or you can find somebody else to get it, in which case you would change, you would maybe insert a new row that has a vendor key, a new one that you've made a relationship with, or maybe just, maybe Rubicon can do it now. So you would change to their primary key as the foreign key. Do all that first, and then once that's all done, I guess we could just show an example. Let's say, let's play this out. Let's say that whoever 23119 is, they're going to take over all of it. I mean, it's probably not totally realistic, but we're just going to say they can take over all these products. So what would you do? In your product table, you would say update product set V code equal to, what would I say, 23119, where V code is equal to Bryson, which is 21225. So you could do something like that, where it equals to it. So you could do something like that. That would be like moving them from one vendor to the other. So let's do that. 2 rows updated. Now let's go back and I don't know why I'm going back to this right here. Now that we've done that, there shouldn't be any 21225s in the product table anymore. So that means we can do what? We can delete that dude from the vendor table. Because he doesn't have any, there's no referential integrity you have to worry about. That's kind of the proper way to do it. But in our scenario, that wouldn't really work. Because it would be a lot of trouble to go to all the subparts of the project and like delete backwards. When all you really want to do is just wipe the slate and say, I forget I even started on that project. You can see how the scenarios are different maybe. You just kind of want to start over. So you can do a workaround around that by doing this. So let's look at our constraint first of all. If you did, there's different ways you can do the foreign key constraint, but sometimes you can name it. It's probably the best way to do it. If you don't, the system will give it a name. Our constraint for that we were just talking about, the one to vendor and product constraint, referential integrity, is called FK, foreign key vendor, because the foreign key V code is a foreign key from the vendor table's primary key V code. So what we want to do is alter that to where I could probably do it directly, but just to be safe, I'm just going to drop it first. So we'll run this. This is how you would drop a constraint. Alter table product, drop constraint FK vendor. So this would also allow us to get around referential integrity, but let's say we don't necessarily want to do it. We still want to have the relationship. So, and you can also like get rid of the vendor without getting, if you could get rid of the vendor, but it would still appear in the child table, possibly, which you don't want to happen. So what you could do, if you want to do the scenario that I had, you want to add this to your foreign key constraint when you add it back using alter table. Just the phrase on delete cascade at the end. So create that, and then go back, and I think I'm going to roll back. Let's see if I can roll back and get everything back. I should be able to, right? This is DML, and I haven't committed yet, and I haven't like exited, done anything that would automatically commit it. So I think everything should be back to where it is. Let's see if it is. Let's select star from product and see if 221, was it 212255, whatever still. Did it actually change it totally? Let's see. Did you roll back more than once? $21225, I think, right? Well, it looks like my rollback didn't work there, but let's go ahead and just power through this. And what we want to do is pick a different one and show how the on delete cascade works. So let's say something we only have like one of in here might be a good one. I think this 25595 would be one. So which vendor is that? It doesn't really matter which vendor, but we're going to go ahead and see. That's Rubicon. Okay, we'll change it. We'll get rid of Rubicon then. So what we'll do is delete from vendor where V code is equal to 25595. Alright, so you saw that one row was deleted even though that guy was in the, that vendor was in the table over here. And what you should see is that that particular product, I forget which one it was, should be gone now. Because what happens when you delete the primary key that's a foreign key in another table, it'll make that particular thing disappear. That child disappear too. Let's do it with the one that's more obvious. So let's see, 1546, just remember that maybe. We'll do where it's got a bunch of them, 23199. There's going to be a lot of these, right? Because that's what I changed it to before. So let's do this. So you got a current count of 12. So after this, you should have what? 12 minus 1, 2, 3, 4 looks like maybe. Let's see. It says only one row deleted, but let's look. Oh, of course, because it's the vendor. So let's look at the products though and see how many rows were deleted. 4 rows. So all the ones. So this is how you get around that reference integrity in a way. You think about the scenario about what you're doing. It should be something like what I was describing, where you really do want to get rid of everything, even though it's a child table, right? And you still kind of want referential integrity because you don't want to add the thing to the table unless, like, for example, you don't want to add the product unless the vendor exists, maybe. Though you do see that you can have nulls in this one because there's a couple. But on the other hand, if you say delete a vendor, you just want to get rid of all the products that are from that vendor. If that's really what you want to do, then you would use on Delete Cascade. So it turned out it worked for us. I was afraid because here's the thing: keep in mind this is going to get rid of a lot of data if you're not careful. But apparently it worked. So we didn't have any like catastrophes from it. So use it judiciously is what I'm trying to say. The long and short of this is that there might be a specific scenarios where you want this to happen, but use it judiciously.